So this is bromine pentafluoride, and so for drawing the Lewis structure, we first have to look at the valence electrons. So if you look at a periodic table, both bromine and fluorine have 7 valence electrons. So bromine has 7, and so does fluorine, but there are 5 fluorines. So that equals 42 electrons. So when you're drawing the Lewis structure, you have to take the bromine and put it in the middle, and there are 5 fluorines, which can be drawn like this. And since each bond has 2 electrons in it, you subtract how many electrons there are. So there are 2, 4, 6, 8, 10 electrons. So that leaves us with 32 electrons to fill the octet. And so if you draw all of those, which can be seen like this, you use 30 of your 32 electrons. So you're left with 2, so that makes bromine have a lone pair. So when you're looking at the 3D structure of this, it can be seen right here. And you can see all of the fluorines that are right here, and also the lone pair that's at the top. So then if you're trying to figure out the electron pair geometry, you have to look at the structural pairs. So there are 1, 2, 3, 4, 5, and 6. So there are 6 structural pairs. So this makes the electron pair geometry octahedral. And octahedral has ideal bond angles of 90 degrees and 180 degrees. However, when you're looking at the molecular geometry, you have to look at the bonds in the lone pairs. So since it's bonded, there are 5 bonds and 1 lone pair. That makes it square pyramidal. And you might be wondering why. And so if you connect all of these fluorine atoms right here by a square, it makes a square. And then you can connect this square to this fluorine, which makes it a pyramid. So this is why it's square pyramidal. But I'm going to erase that so we can do polarity. So you can pretty much just look at this one and know it's polar because of the lone pair, but you can also look at the dipole moments. And so you can draw your arrows and they're going towards the fluorine because fluorine is more electronegative than bromine. And so all of these 4 that were in the square cancel, but you're left with this arrow and your lone pair, making it asymmetric, which makes the molecule polar.